Welcome, my dear JEE 27 and 26 students. Welcome to the class 11 syllabus. We are on to the next chapter. After doing Newton's law of friction, we are going to start off with work, power, and energy. So I hope you are all excited. You are all eagerly waiting for the next chapters to start. Very, very useful chapter, not just in 11th, but also in 12th. Almost every single chapter has that work or energy calculation or that concept which is used for other concepts, isn't it? Yes, Ramya, let's start. And we have started. Hi, Bala, Srimati, Dhaya, Yogesh. Welcome aboard. And very, very happy Ganesh Chaturthi to all of you. I hope you are enjoying with the time with your family and also using these holidays for backlog clearance. Yes, enjoy the festival and also cover up whatever you have missed in this time to come, right? Hi Vasula, hi Bhanu, nice to see you back. Welcome aboard. And this is your Captain Shreyas. If you're new to the channel, quickly say hello, hi in the comments if you're watching recorded or in the live, say hello. Where are you from? Which standard, right? So that's my brief intro. I did my research from IIT Bombay, BTech from NIT Nagpur. Yeah, I mean, what else? Like everything is there over here. Cool. How many years of PYQs would you suggest me to do? Bhanu, I would not really suggest years of PYQs, but rather I would say go at least till 2015. But you don't have to do all the PYQs because if you see the last 4 5 years, no, there are thousands of PYQs and many times the same thing is getting repeated. So rather than doing the repeated thing, you can go for the variety. So let's say you take the year 2022. If there are example 500 PYQs, maybe you can do 100 or 200 PYQs from 2022. But it should be of different variety. Same thing with other years. So variety should be there. But before 2019 and all of that, you will hardly see many questions because there were not many attempts before, 2019 and all of that. Okay. Yeah. 26 aspirant Ramya. Wow. That's great. I'm pretty sure your backlogs are going to be cleared in this series because a lot of 12th standard students are over here. And kudos to all of you guys. Hi Bala. Hi Silu, welcome, 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 Akhil, welcome, Pritija. Good evening. So let's begin. And before I begin, let me also remind you that if you have not yet registered for MVSAT, I just need to keep reminding you, please register because the dates are approaching closer and closer. 4th, 5th, 11th, and 12th October. I will share the syllabus if you want on the Telegram channel. The Telegram channel link is there in the description box. But register for it because the moment you register, right, you are getting lots of materials. You are getting lots of pamphlets, brochures, everything which is useful for your preparation and your counseling and your awareness. So you start getting just those free materials right after you register. Plus, after the test, you get to know where you stand at a national level. Plus, lots of prizes to be won and scholarships also. So don't miss this chance. I mean, give the scholarship test everywhere, I would say. Yeah, see what you win. And if you're great at studies, so you should give because then you will get nice prizes, right? All right. So I hope you'll register, guys. Where is the link? The link is there in the description box of this particular video. You can just go down over here and you will see right over here MVSAT register now. Just click on that link. It will open up. All the FAQs are there, syllabus, everything. It's for all the students, 8, 9, 10th, 11th, 12th and droppers. You can register using your details and that's it. Just say submit. You will be done. Okay. Now let's understand this concept of work and energy first. So imagine that we have a bank of sorts. We have over here a bank. We have over here a bank, and bank stores a lot of money in the vault, right? So there is a vault in which there is a lot of money, and then what happens is we have a pandu. We have a pandu, and this pandu has gone out with a beautiful champa over here, and after they went out, they have to pay the bill at the restaurant. So there is a waiter over here. He's the Pandu waiter. He's the Pandu waiter. And to this Pandu waiter, you have to give the money because you have eaten at the restaurant. So what this particular Pandu does is he has, the mobile phone. he scans that QR code or whatever this dude will show. This dude will show some QR code or something like this, and he scans that using his mobile phone, and he transfers the money. Yeah, he transfers the money. And when I say he transfers the money, what happens is from this bank, this money will go from here to this guy's account. So there is some account transfer which is happening, and he is using essentially some kind of payment gateway. In this case, he is using UPI. You can also directly give the cash. You can also do account transfer. You can write a check. So many options are there. He chose UPI. He can also swipe a credit card or debit card. Now, the same analogy, now this analogy basically works for the concept of understanding, work and energy. I'll tell you how. Imagine the bank is like our universe. The bank is basically the universe. These Pandus, Champas, waiters, etc. They are our systems. This is one system. This is another system, etc. Each person, each system has some money in the bank. Same way, the system has some account opened in the universe. That is, they have some money in their account. They have some money. This is basically your money which is there in the account. This is the money in the Pandu's account. This is the money in the waiter's account. This money is basically like energy. This money which is stored is basically like energy. The process of transferring the money from one system to another system, from one person to another person, that process of transferring is basically called as work. Is basically called as work. And the agent which you use, the medium that you use, whether it is check, whether credit card, whether UPI, whether any other method, that agent which is used is basically called as force. That is basically called as force. Now, the entire chapter becomes like a summary over here in this slide. The universe has some energy which is possessed by different bodies. Like somebody might have kinetic energy, potential energy, chemical energy, muscular energy, this energy, that energy, heat energy, light energy, everything. When one system gives the energy to the other system, it can't happen magically. So it has to be transferred from one system to the other system. This process of transferring energy happens via work. So work is the process of transfer of energy, and you need some kind of medium method to transfer that agent who transfers that energy is basically called as force. So without force, there is no possibility that you can transfer the energy. Force is needed always. And in this entire scenario, you will also notice that when you transfer the energy, this person's energy increases, this person's energy decreases. It's like the money goes from here to here, but the bank is always rich, they say, right? The money, one person might become rich, another person might become poor, but a bank never becomes poor, the bank always becomes rich. Same way over here, the universe is always rich with energy. The total amount of energy in this universe is always going to be constant. Did you understand the whole concept, my dear warriors? Yeah, everybody? How to know various models? Well, look of it only you will understand. But if it looks very similar, it is same model, right? Okay, right. Can you mention the lecture numbers here after? It is difficult to search and watch. Listen, I have done a very beautiful thing over here. I don't know whether you have noticed. Just go to the home page. Okay, you don't have to worry about lecture numbers. See, for example, class 11th. Okay, go to this playlist. I have arranged it serially only. Okay, this is the first lecture you should watch. This is second, third, fourth, fifth, like that. If you go in order, you will complete the entire syllabus chapter by chapter. Okay, if you want, but still I can mention lecture 1, lecture 2. That's not a big deal. But yeah, I have arranged it in a beautiful playlist. Same thing for 12th and other things. Okay. Yeah, Abhijit, you can definitely prepare for IOQM. Yes, you can just prepare for IOQM only. Yeah, you have the options. There is an IOQM batch by Abhay sir and our mentors. You can definitely do that. Okay. Now that we understand this whole concept, there are many examples where the agent of force is doing work. For example, you drop an apple or a ball, the gravity is doing work, force is applied, and gravity is definitely doing work. It is transferring the energy from earth to the ball. Yes, without the force, gravitational force, the earth's energy wouldn't be going to the ball, and basically the gravitational potential energy is going into the kinetic energy of motion of the ball. You are pushing a box, your energy is getting transferred to the box. So that is happening because you are pushing it. Without you applying the force, magically can I say, ooh, like this I will do, and box, move, box. I will do like this, box, move, box, move. I can't do such magical things. So, you need to push it, you need to pull it. So that force is needed, which is that agent to do that work. Now, if I ask you, in both these scenarios, where would the work done be more? Yeah. In this scenario, the same person is pushing it from here to here versus the same person is just pushing it from here to here. Case number 1 versus case number 2. Where is the work done more? Think logically. That same force, I'm pushing till here. I did some work. I push it more. Obviously, I will do more work. This extra distance demands extra work to be done. So, case number 1, obviously, the work done will be more. Yeah. So, the work done is more in case number 1. Perfect. If you ask me this scenario where this box is moved from here to here by applying a small force of F versus the first scenario where the same box moved by the same displacement, maybe sooner, but with more force. Here you are pushing more for that same distance, here you are pushing less. What do you think? Where is the work more? First scenario or second scenario? Well, you might think the work is same, but actually it's not, because here I am applying less force to move it till here versus here I am pushing it more of my energy will transfer. This agent is more powerful. So yes, more work will be done again in scenario number 1. Is that clear? So more force also means more work. Also more displacement means also more work. Lastly, imagine this person is pushing it normally like this from here to here versus another person applies that same force for the same displacement, but he's pulling it at an angle. He is applying that force at an angle versus pulling it like this. Where do you think more work will be done again? In scenario 1, this force can be split into 2 components. One component is here versus another component is here. This component is doing work, whereas this component over here is not going to do any work. Reason? You are moving horizontally, so only that force in that direction will end up transferring the energy. This force is probably just helping with the normal and balancing mg. That's all. It's not moving that object up or down. So this component of the force is not doing work. Only the component of the force in the direction of the displacement is responsible for transferring energy to the box. So in both these scenarios, if you notice, this force is less as compared to this force. Horizontal component is less as compared to the actual force. So here less work will be done. Here more work will be done. Hence the answer to this particular question is scenario number 2. So here that entire force is utilized to move it. Here a part of that force in this direction is utilized to perform that work. So that is the reason why lesser work in the first case, more work in the second scenario. Everyone, hi Prem, hi everyone, good evening, Yuvasri, welcome aboard. I'm from Chennai and this video get posted. Yes, it will be posted after the lecture. Every lecture gets recorded, but obviously you should watch it live. And don't worry if you miss something, you want to recollect, revise, always you can watch the replay of the class. I can just show you the playlist, right over here. All the lectures are stored over here in this beautiful playlists which are arranged just for you. Past live streams, class 12th syllabus, class 11 syllabus, the older series of ROAR. I'll also update the what do you say, Nurture and Pathfinder, and J Advanced playlist also. I will update it very soon. Okay, cool. Having said that, let's move ahead with the formal definition of work. So my dear warriors, work, because it is proportional to the force, proportional to the displacement, but actually forces component along the displacement. So work is F dot S, which is as good as saying work is F cos theta multiplied by displacement. Whenever two vectors are multiplied with their magnitudes and the cosine of the angle between them, and the output is a scalar quantity, then you can use a dot product. So it is F vector dot S vector. That is a scalar product or a dot product. Okay, so this is a scalar product or a dot product basically. So it is a dot product of force and displacement. Dot product rules I've already taught to you, in the previous lectures right over here. Yeah, so if you have missed watching the vectors class, so please check it out. It's very, very important. Yes, we have done vectors right over here, vector subtraction, addition, vector multiplication, all of this. Okay, so please check it out. Vector multiplication, dot and cross product. I've done it almost more than a month back. Great. Now, what is the unit of work? Well, if you ask me, it's very obvious here. This is Newton and this is meter. So if you take a Newton of force and move it in a direction of the force by a meter, Newton into a meter is going to give me the SI unit, which is basically a joule. This is basically a joule, which is nothing but the SI unit, which is the most common unit. But you can also have the CGS unit. So force will be measured in diens and displacement will be measured in centimeter. That will be then giving the unit of erg. This is CGS unit. If you ask me the comparison between the two, then 1 joule of work is 10 raised to 7 ergs. If you have 2 joules of work, it will be 2 into 10 to the power 7. So this is the conversion factor which you should be very well aware of. Also remember, work is a scalar quantity. It's very important to know this. Work is a scalar quantity and it has no significance. Direction has no significance here. There is no point of you telling me I did work in north direction or south direction. It doesn't make any sense or it adds no value to my calculation. Okay, no matter which direction you do the work, it has no significance for me. You have done that work, that's it. That much energy has been consumed. That's it. End of story. It does not follow any other rules of vector addition or you cannot multiply it like vectors. And anyways, you are seeing there is dot product also. Perfect. So, a lot of people I have seen, they get confused the moment I say work is a scalar and then I tell that work has sign. Work has sign associated with it. Lot of people wonder how can work have sign associated with it? Is it possible for work to have sign associated with it? The answer to that is yes. The answer to that is yes. Okay, I'll give you a few examples out here. Imagine there is a train versus a bus versus this car over here or a van. This is a bus. This is your train. In the Spider-Man movie, you would remember, yeah, Spider-Man will come over here to stop the train whose brakes are failed. If you have not watched Spider-Man movie, it is okay, guys. Just I'm pretty sure you know who Spider-Man is. Don't ask me to explain who Spider-Man. Spider-Man is using his webs. Okay, he's using his cobwebs and he attaches those cobwebs to the buildings, nearby buildings, and he's trying to stop. He's trying to stop a moving train. Trying to stop a moving train. So if you ask me what direction is the force applied by the Spider-Man, the force is in this direction. He's trying to stop it. Whereas the displacement of the train is in this direction. Displacement of the train is in this direction. Now, if I tell you where is the energy going from, to whom, it is going from the train to the Spider-Man and his cobwebs, because slowly the train decelerates, so the energy is reducing. So somewhere else in the universe the energy should increase. Whose energy is increasing? The cobwebs energy. Yes, the energy is being stored in the cobwebs. So this Spider-Man is doing negative work on the train. When he is doing negative work on the train, that means he is sucking away the energy from the train. So this is very, very important. So he sucks away the energy. He's absorbing that energy. He's absorbing the energy from the train. That is why I will say negative work has been done. Negative work has been done. Yeah, I hope this is absolutely clear. Can I clear AQM by self-study? It's little difficult, Abhijit, but because it's not an easy thing. JEE means I would have said okay, but IOQM is really tough. Without, I mean, I'm telling you, even a JEE teacher can't teach for IOQM. Okay, so you should appreciate that level of difficulty. When will I start live academic sessions or class 10 channel? Yes, I will start it soon, my dear. Yeah. Yes, class SST, class 10 SST also I'll be teaching. Class 10 social studies also I'll be teaching. Yes. Okay. Next example, imagine another day a bus has spoiled or engine failure happened or something happened. So next day we called Superman. Next day we have called Superman. So Superman has come over here. Okay. This is the cape of the Superman. Okay. And Superman is now pushing the bus. So what is Superman doing? He is pushing and accelerating the bus. In this scenario, the Superman has applied the force in this direction. The displacement is also in the same direction. The Superman is giving the energy to the bus. He is giving his energy. He's not absorbing, he's giving it. So whenever you give, he's giving energy, then it is said to be positive quantity of work. Okay, so positive work is when you give the energy, so then that force is said to do positive work. So the force and the displacement are in the same direction. Negative work, it is in the opposite direction. Another day what happened is Godzilla came. Okay, this is our Godzilla. And Godzilla is angry. Okay, you can call him Gojira also. So Godzilla came and Godzilla took one car and he wants to throw that car, like they show in that Gojira movie, right? So he's taken that car, he's lifted that car, but before throwing it, director has told Gojira that you have to, do some action. So what Gojira is doing, he's taking that car and he's rotating along with it. Okay, he's going to do like this and then he's going to throw that car. Okay, just like they do in shot put and all, or javelin throw. So Gojira is rotating. Gojira is rotating like this. So in this scenario, as you can see, the displacement, okay, you can rotate like this or like this. The displacement will be like this, and the force by Gojira on that car will be like this, which will be now perpendicular, to the displacement. In this scenario, as he rotates, he is not giving the energy nor is he sucking the energy. The car is still moving with the same speed, same kinetic energy, same height, no change in potential energy, no chemical, light, heat, energy being transferred. So here the energy is constant. So in this case, it will be essentially zero work done. There is no transfer only of energy. There is no transfer of energy. Neither are you absorbing nor are you giving it. Is this absolutely clear, everyone? Jolly, whatever your doubt is, please tell me. Sir, can you please give me some details about online classes for JEE Mains? Yes, I will give you. And we do it towards the end, my dear. Okay, we'll concentrate on the class. Just tell me at around 7:30, 7:20. So then I will tell you. Perfect. So now that we understand, work also has sign. So in general, I can say whenever the angle is acute or 0 degree, then you can see in our formula, cos value will be positive in the first quadrant from 0 degrees to 90 degrees. So like this, the forces, or like this, or like this, or like this, till here 89.9999 degrees, the work will be positive. If you are exactly at 90 degree, cos 90 will be, how much is cos 90? 0. Sin 90 is 1, cos 90 is 0. Okay, work done will be 0. And the force and the displacements are perpendicular to each other. But when the force is at an obtuse or at exactly 180 degrees to the displacement, remember cos in the second quadrant, trigonometry, it is negative. So work done is also negative. Is this absolutely clear? Okay. This first scenario you can see is the Superman pushing the train, force and displacement making acute angle. Second scenario, force and displacement making obtuse angle or 180 degrees. Third scenario, work done 0 because force and displacements are perpendicular to each other, right? So these are the three sign conventions. Perfect. Okay, perfect. Hi Jasveer, thank you. Welcome aboard everyone. Yeah. Bala, I will tell you about self-study, everything. Just maybe I think, we'll do one thing. We'll do a chit-chat session this Friday or Saturday. Okay, how about this? Because many of you have many doubts regarding preparation. I feel that I make videos, but still you guys get doubts, which is very good. I'm very happy that I'm inspiring all of you to think like that. And I will keep inspiring you, and I will keep making every day one or the other videos just for your preparation, just for your guidance, just for your strategy, just for your counseling, everything, guys. And I will also come live. Maybe we'll do a chit chat session also. Okay, great. Sir, what if there are multiple forces, sir? What if there are multiple forces acting on the body? Let's say I'm pulling this body here. Normal is there, friction is there, tension is there, spring is there, that is there, this is there. 100 forces are there. So what to do in that scenario? So I'll tell you what. If you want to find the total work done by all the forces, you find the work done by the first force, work done by the second force, and so on and so forth, work done by the n forces. This is not vector. Do not put bar. Okay, don't put bar because they are not vectors, they are scalar quantities. What is work 1? It is the first force into the net displacement. What is work 2? It is the second force into the displacement. Displacement is the same. When you move, this force also moves, this force also moves, this force also moves. All the forces are moving by the same amount into last force, which is their nth force dot displacement. As you can see, everywhere the force is different, displacement is the same. So I can take displacement common. So it will just become F1 bar plus F2 bar till the nth force dot product with the displacement. What is this quantity? This is nothing but the net or the total force dot displacement. So whenever you want to find total work, either you can add all the work, which is done by individual forces, or you can take the net force and then multiply it with the displacement dot product. Then also you will get the same answer. Both are same. It's just a matter of choice and convenience. Just a matter of choice and convenience. Excellent. Great. So I think it's good time that we start solving some questions coming up on your screen. Here is the first one. Find the work done by the external force of 5 Newton, frictional force, gravitational force, and normal force reaction on the mass 10 kg when displaced by 2 meters. So you have to find the work done by friction also, external force also, gravity also, everything you have to find out. Okay, bro, let's do it. First of all, as you can see over here, there is one external force. There will be 100% one normal. There will be also one weight, and friction will be acting backwards. So let's draw all that, find all that, and then let's find out the work. This is our normal force. This is our mg force. This is our frictional force. How much is the value of each one of them? First of all, this force is already given to be 5 newtons. Mg, mass, is given to be 10 kg. So it will be 10 into G, which is 10, which is basically 100 newtons. This normal force will balance weight So that will be also 100 newtons. Friction is going to be mu into n. Mu is given to be 0.1. Normal is given to be 100, or we found to be 100. So this will be nothing but 10 newtons. This is the frictional force. So we know the external, normal, weight and friction. Now let's do one by one everything. Starting off with the external force. Work done by external force is that external force into the displacement into cos theta. So what is the external force? 5. What is the displacement? 2. What is the angle between force and its displacement? Both are in the same direction. Means the angle is 0. Yes, so it will be cos of 0 degree. So 5 2s are 10 into 1 is just the same number. So 10 joules is the work done by that force. 10 joules is the work done by this force. Great. Can we similarly figure out work done by normal and weight? Why not? Work done by normal will be the normal force multiplied by displacement multiplied by the angle between the normal and the displacement. Normal is up, displacement is horizontal. Can you see the angle is 90 degree? So this will be nothing but cos of 90. Whenever 90 degrees is there, that's at 0. So work done by normal is going to be 0 because it is perpendicular. It's not adding to the energy nor is it sucking the energy. Same thing for the weight. Work done by the weight will be the mg force multiplied by displacement. Again, the angle is 90 degree. Displacement is here, weight is down, so you can see 90 degree. So again, the work done by the weight mg will be 0. Friction, work done by friction. It will be frictional force multiplied by displacement multiplied by the angle. Friction is this way, displacement is the other way. The angle between friction and displacement 180 degrees. So you are going to put 180 degrees over here. Frictional force 10 Newton, displacement 2, cos 180 is minus 1. So this will be minus 20 joules. This is going to be minus 20 joules. Yes, perfect. Next, if total work was asked, here it is not asked, but chumma I'm saying, if total work was asked, what will I do? I will add the work by literally all the forces. This force did 10 work, okay, this force did 0 work, okay, this force also did 0 work, okay, and what else is there? This force has done minus 20 joules of work. So hence the total work done is minus 10 joules. Okay, so this is the total work done, which is how much? Minus 10 joules. Everybody with me? Understood? Happy Ganesh Chaturthi, Rathal. Yeah. All right, Yuvasri. Yes, we'll definitely do that. Jolly time. Yeah. Like I said, I'm not sure what was your question. Jolly time. My name is Sudarshan. Sir, please answer. I don't know. I can't see your doubt. Jolly. Okay. All right. Let's go to the next question on your screen. Here it is. Find the work done by the gravitational force on each block when the 2 kg mass has moved 3 meters. Find the work done by the gravitational force on each block when the 2 kg mass has moved 3 meters. Interesting. Can we also find the work done by the tension? We will see that later, but first let's look at gravity. So 1 and 2, so the 2 kg mass will go down by how much? By 3 meters. Okay, so it has come down over here like this. It has come down over here like this. Displacement. So obviously 1 kg block is going to go up by the same amount of 3 meters. If you ask me the gravitational force on 2 kg block, the gravitational force on 2 kg block will be 2g. The gravitational force on 1 kg block will be how much? It will be 1g. So let's start one by one. The work done by gravity, on the 2 kg block will be the gravitational force 2g, displacement 3 multiplied by the angle between displacement and the force. Force is also down, displacement is also down. So angle is 0. So cos 0. So how much will it be? 2 into 10 into 3 into 1, cos 0 is 1. So this will be nothing but 60 joules. 60 joules is the answer. Very good. Next important thing, work done. See, our job is done, but this is an additional question which I'm asking to you. What is the work done by gravity on the object of 1 kg? So that will be the gravitational force on 1 kg, which is 1g, displacement, which is 3 meters, and the angle between both the force and the displacement, that is 180 degrees. So cos of 180 degrees. Correct? 180 degrees because they are both in opposite directions. So this will be nothing but 10 multiplied by 3. Cos 180 is minus 1. So this will be minus 30 joules. That is the answer. Everybody clear about this? Perfect. Sir, what if there was a question to find the work done on the by the tension? Then you will take tension force and multiply it by the displacement. So tension you can find by Newton's laws, 2m1 m2 g by m1 plus m2, and then again multiplied with the displacement. But for which body will tension do positive work? For which body will tension do negative work? Well, if you observe carefully, tension is going to be like this here, and tension is going to be like this over here. So for this body, tension is opposite. So for 2 kg, tension will do negative work. But for 1 kg, tension and displacement are in the same direction. So it will end up doing positive work. Is that clear, everyone? Yes, others, that is absolutely correct. Yeah. Just follow with the flow. Bhanu, you will complete everything. Okay. Moving on to the next one on your screen. There is a certain block of 1 kg which is pushed up a surface of an incline at an angle of 60 degrees by a force of 10 Newton parallel to that inclined surface of 10 meters. The work done against the frictional force is how much? The work done against the frictional force is how much? Okay, let's start drawing the free body diagram. See, the weight will be having two components. One component will be like this. The other component is going to be like this. Mass is 1 kg. So when you have this mass of 1g, this particular angle will be 60 degree. So this will be 1g cos 60 degrees component, and this will be 1g sine 60 degree component. Friction, well. If you ask me, sine 60, that's root 3 by 2. So therefore, this will be 5 root 3 Newton. This will be 5 root 3 Newton, as you can see, because G is 10. Sine 60 is root 3 by 2. So 10 by 2 is 5. So 5 root 3. Okay. And here, G cos 60 means 10 into half, which is basically 5 Newton of force. Apart from that, there will be a normal reaction right over here. Okay, these are the forces. So you're pulling it up by a force of 10 Newton, 10 Newton parallel to 10 meters along the inclined surface. Okay, so if you now want to calculate the work done by friction, it will be frictional force multiplied by displacement multiplied by basically the angle between the force and the displacement. Now, see guys, it is not mentioned really how are you pulling it up or down, but I can see every answer is positive. So I'm assuming that the block is also going down, because otherwise, you can have positive answer also, negative answer also. So I'm assuming over here you are moving it 10 meters down the inclined plane, because then the frictional force, if you are pulling it in the this direction, the frictional force will be like this over here. The frictional force is going to be like this over here, and you will see that the angle between them will now be 180 degrees. So the answer technically should have been negative, but they have not put any negative values over here. They have not put any negative values over here. So we will just take the mod value as it is. Okay. Technically, the answer should be negative, because friction and our displacement will always be opposite, right? If I move like this, friction will be here. If I move up, then the friction will be here. Any case, it will be cos 180 only. So how much is the frictional force? Frictional force is mu into n. Displacement is how much? 10 meters. Cos 180 is -1. Mu value is 0.1. Normal force will be balanced by this. Yes, normal force will be balanced by the 5 newtons of force. So that's why you're just going to put 5 and this 10 is there and this -1 is there. So this is just going to become 0.5 into 10, which is just going to be 5 joules with a negative sign. But if you ask me what is the work done against the friction, I'm just going to take the mod value, which is 5 joules. Okay, which is basically 5 joules right over here. So that is the answer. Okay, that is the answer. Okay. In the exam, don't get scared. Sir, negative answer is not there. Just mark the positive value. Ideally, it should be what is the work done by friction. If it is asked, it will be -5. But here the question asked is what is the work done against the frictional force. So I am doing a work of 5 joules against the friction. So it's a play of words. That is why the answer is +5. Okay, cool. Hi Ansika, hi Sakti, welcome Hazad, everyone. All right. Moving to the next question on your screen. There is a force of so much newtons which is applied on a particle. Displacement is so much. What is the value of B in this expression so that the work done is 0? Well, let's try to recollect. Work, if it is in IJK form, I will better use the dot product formula, F dot S. The work done is 0. The force is 2I cap plus B J cap plus K cap. Displacement is I cap minus 2J cap minus K cap. Okay, perfect. Perfect. Okay. What can you understand from this particular statement that the work done by the force on the particle is 0? It just means that the force is perpendicular to the displacement. And whenever the two vectors are perpendicular, their dot product will always be 0. You can see that. Exactly what we are expecting it to be. Now, whenever you have to do dot product, always I cap will multiply with I cap, J cap will multiply with J cap, and K cap will also multiply with K cap only, nothing else. No mix and match, only same to same. Now 2I into I into I is 1, so 2 into 1 is basically 2. B into -2 will be -2 times of B. K into minus K, which is 1 into -1, that is -1. So therefore 0 will be equal to 2 minus 1, which is 1, minus 2B. If you want, you take 2B on this side, which is 1. Therefore B value is half, which is 0.5. So B option is the right answer, which is half. Everyone with me on this? Clearo how to solve these kind of dot product based questions also. Simple rules of dot product. Okay. Negative marking is there, Yuvasri. So guys, please check out this particular video which I have posted everything about JEE. I think somewhere here. All about JEE 2026. All about her. Ayo, what her, man? Who is that her? JEE. This autocorrect also, no? Crazy. So I think somewhere, yeah, this JEE 2026, all details, eligibility, pattern, difficulty, competition, and all other things. So watch this big video which I have made. Okay, it's very important. I have mentioned all the details right from the pattern to the competition to eligibility. So check this out. You will understand. Just 12 days ago, I had made it. It's got decent views also. Okay, moving on to the next one coming up on your screen. Here it is. This is your homework question. Now, please make sure that you're solving the homework and posting the answer where? In the comment section. Okay. After some time, you can just post the answer in the comment section, even if you're watching it recorded. All right. Okay. Great. Why can't it be option A? Ayo, over here option A and B both are same, huh? This is a printing mistake then. I think maybe this half was not there. Okay. So yes, half was not there. All right. Cool. Okay. Happy Ganesh Chaturthi, Sai. All right. Perfecto. Let's go then to the next concept of work done by a variable force. Imagine in the previous scenarios, our force was constantly applied. What if the force is only changing? So let's say I am going from here to here. Okay, this is my initial point, this is my final point, and at every place my force might change. It's a variable force. Here it is different, here it is like this, and here it is like this, then here it is maybe backwards, and here it is like this. Okay, every single place my force is different. So what I will do in such scenario, I will move a small amount. I will move a small amount over here. Okay, I will move basically a small amount along that path. That small displacement, I will call it ds. What will I call it? I will call it ds. At that place, the instantaneous force is F. So the small work, in moving a small displacement amount will be dw. How much will it be? It will be dw. And that small work will be that force at that place dot product with that displacement. So now if you ask me the total work from that initial location to the final location, that will be the sum of all the work, by moving small amounts or by moving small displacements. So when I say sum of the work, all the work means integration. Integration is another word for summation. So the total work done will be the integration from the initial location to the final location of our force with the displacement. This is very important. Integration of force with displacement. So whenever the force is variable, then you have to integrate the force. So all the rules of integration are now valid. And whenever integration comes, the other concept which comes is area under the graph. So if there is force here and displacement here, means if you draw a graph of force versus the displacement, how the force is changing with the displacement, and let's say our graph is like this. It starts like this and increases, decreases, something and all is happening. This is my initial location, this is my final location. What you need to do is basically measure the area under the curve. What will you do to measure the work? You'll just take the area under the curve. That area represents the work done. So this work is also area under the force versus displacement graph. Area under the force, that same force over here, versus the displacement graph. Okay, very important. So I can just make this bigger now. Yeah, this is the formula. Sometimes the question can be graphical, sometimes the question can be based on integration also. Both kinds of questions can come. Okay. All right. Anamadzu, maybe someday I will explain you about the negative marking of JEE Advanced, maybe not now. Okay. So let's focus on this class. Now, sometimes what might happen is, your force might be in 3-dimension, displacements are happening in 3-dimension. So what to do in that case? See guys, it's very straightforward. The work is integration The work is nothing but integration from initial to final location of our force with the dot producted with the displacement. What you can do is you can write the force as some x component, some y component, and some z component. Okay, this is your force. And the displacement also will be some small displacement in the x direction, some small displacement in the y direction, and some small displacement dz in the z direction. So now, if you basically integrate this, before that, we'll do the dot product operation. As you can see, x component should multiply with x, y should multiply with y only, and z should multiply with z. That is the rule of the dot product. So here what I will get, initial to final location. Here I will have fx, I will have fy, I will also have fz, and here I will have dx, here I'll have dy, and here I will have dz. Simple addition of that. That is what I'm going to get. But in integration, whenever you have three separate terms, three terms being added, you can separate it out individually and integrate them. So essentially, this will be nothing but three separate integrals, which is also good as saying work done in x, work done in y, and work done in z. So you can just say this is like from initial to final location. This is initial to final location, and this is also initial to final location. Here, this is every calculation which is done only in the x direction. Here it is in the y direction, and here it is in the z direction. Okay, so this is completely in x, this is completely in y, and this is completely in z direction. Okay, separate. So this is how you can solve a three-dimensional question also. Three integrals will be there in x, y, and z separately. Don't worry, I'll give you examples. You'll get a complete idea of it. Okay. Koncham Azad. Yeah. I have my family history from Andhra. That's the reason for that. Okay. Now, unfortunately, the answer is marked over here. So I'll do one thing. I'll just eliminate the options so that you can't see. Okay. Now let's solve. Four options, 18, 13.5, 9, and 4.5. A force is acting on a particle. Graphically, it has been represented. What is the work done to move it from 0 to 6 meters? So the question is now on the work done. Now, whenever the question is on work done and graphically force and displacement are given, it is nothing but area under, like I just told you, force versus displacement. Area under force and displacement graph. That area gives the calculation of the work done. Okay, so let's do that calculation. Here, that area, as you can see, is a trapezium. It is nothing but a trapezium. And for a trapezium, to calculate the area, you need the parallel sides and you also need the height. This side length is going to be 3 units. This side length is going to be 6 units. The height is going to be 3 units. So what is the area of a parallelogram? Of a trapezium? It is half multiplied by the height multiplied by the sum of parallel sides. That is the area of a parallelogram. Trapezium. My bad. What is the height? Height is 3 units. The sum of parallel sides 3 and 6. So 3 plus 6, which is 9. 9 3s are 27. So it will be 27 by 2, which is 13.5 joules, which is option number B right over here. So you should know the formula of the area of a trapezium, all these things. Okay. Sometimes what people do is they calculate rectangle separately, triangle separately. Guys, you don't have so much time in the exam. Be smart and be a little bit, proactive in such things. You should not forget those formulas. You should know all the standard areas or and volumes, etc., perimeters of geometrical figures. Cool? Yes, Prahadi Swaran, you can definitely watch the classes for NEET also. Why not? Can we multiply the area where of triangle and the area of the triangle, not multiply, add, you mean, Bala? Yes, you can do that. Like I said, don't do that. It is waste of time. Directly use it, because why do you want to take 2 extra steps? By the way, one more thing over here I wanted to tell you. Whenever you have this graph of force and displacement, and let's say the force is like this over here, and then it goes down over here, and then it goes up over here. Whenever the graph is on the upper side, it is positive work. Okay, sign matters. And whenever the graph is below over here, then it is negative work. Keep that in mind. Okay, so which part of the graph it is, that also decides the sign. If it is above the x-axis, it is positive. It is below the horizontal axis, it is going to be negative work. Luckily over here, all the graph was above, so everything is positive. If it was below, then it would have been negative also. Okay, so let's see whether we can solve this particular question right over here. But I think before this, we should go to some other question. Okay, we'll do this and then we'll go to that. That will be better. A force of alpha plus beta x square acts on an object in the x direction. The work done by the force is 5 joules when the object moves by 1 meter. If the constant alpha is 1, then what will be the constant beta? Look at it, the force is a function of x, it is variable force. That's the first thing I noticed. This force is a variable force. And the total work done by it is already mentioned as 5 joules. So clearly we can just say work, which is integration of force with respect to displacement. Here everything is in the x direction, so ds I will not write, I will just write dx from initial point to final point. If you're still confused, no issues, I will put ds only. Okay, now let's substitute every single value. Work is given to be 5. Okay, integration. Force is given to be alpha plus beta x square, where alpha is 1, beta I don't know, x square is a variable. Okay, instead of ds, look at it, I am moving in the x direction, so slow movement in the x direction, that means all my displacements will be dx, 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 like that. So I'm just going to put dx over here. Limits of the integration also important. It is displaced by 1 meter. So you start from x equals to 0 to x equals to 1. So that is the displacement. It is clearly mentioned. I am moving it by 1 meter. So from x equals to 0 to x equals to 1 would be the displacement. Okay. Now, you are see there is no weightage of this chapter. In fact, this chapter is used everywhere. In electrostatics, work per energy is used. Magnetism, it is used. Fluids, it will be used. Thermodynamics, it will be used. Right? Every single chapter is going to use work per energy. So if you ask me the weightage, I don't know. Okay, because it is used everywhere. I would then say it is 100 marks. Right? Even in modern physics, concept of work, kinetic energy is used. Okay, so let's integrate this, guys. So plus is there, so we'll need to separate it. So we'll just have integral dx from 0 to 1 plus beta will be there outside. Integral of x square dx again from 0 to 1. Okay, so what is this going to be? Integration of dx is basically x only. So put the limits as it is. I have not yet substituted. Beta x square's integration is x cube by 3. Okay, I put the square brackets to signify limits have to be put yet. Okay, 5 is equal to, first put 1, then put 0. So 1 minus 0 over here. Okay, then beta over here, first put 1, then put 0. So it will be 1 cube by 3 minus 0 cube by 3. All right. So therefore, 5 will be equal to, you have 1 over here plus beta into, this is 0, so 1 by 3. So beta by 3. So this will just become 4 is equal to beta by 3. So therefore, beta is equal to 4 into 3, which is 12 units. So 12 units, which is option number C. That is the absolutely right answer. Yeah, perfecto, amazing. In which cases need to integrate or differentiate? See, whenever you need to add, accumulate, integrate. Whenever you need to find the rate, instantaneous value, okay, slope, you need to differentiate. Simple. Number two, if you know the formula, then you automatically know whether to differentiate or integrate. Like from velocity, you have to find acceleration. You will differentiate because rate of change of velocity is acceleration. Rate means derivative. Whereas from velocity, you have to go to displacement. Then you will integrate because remember, area under velocity time gives you displacement. So that's how you can do it. Cool. Number three, another way is if you know a particular quantity is the derivative of this, then going reverse will always be integration. Like velocity is the derivative of displacement, rate of change of displacement. So if you go from velocity to displacement, it is opposite of derivatives direction. So it will always be integration. So multiple three ways I have given you how you can figure out or remember whether it is derivatives or integration. Okay, NT square S. Perfecto. All right, all right. Now let's go to this question, but I think we need work kinetic energy theorem for that. So I will not do this right now. We will do it after work kinetic energy theorem, which I'm going to teach in a bit. Okay, but before going ahead, let me give you more questions on this. Let me give you more questions on this. Okay, this is very, very important. Imagine our force vector is xi cap minus y square j cap, and I am moving from the motion is from the origin to 2 comma 1. Question is, can you figure out how much work is done? Can you figure out how much work is done? Let's try to do this question. This is a question of 2D or 3 dimension also. You can do the same way. Let's see how to do it. What did I tell? The moment you have a 2-dimensional or 3-dimensional problem where the force itself is not same, it is varying, then basically when you do the dot product, you will find the x work separately, y work separately, z work separately, and add all the three of them to get the total work. So over here also I can use the same logic and I can say that the total work done will be the work done in x direction plus work done in y direction plus work done in z direction. Good part, work done in z is 0 because there is nothing in z. Okay, the work done in x direction will be nothing but the force in x into displacement from initial point to final point. Work done in y direction will be the force in y direction in the y displacement from initial to the final location. Okay, what is the force in the x direction? It is x. So put dx, integrate. What is the force in the y direction? Well, it is negative. So I'm putting minus and putting y square and I'm putting dy. This was anyway 0. So I'm not carrying it forward. Limits are remaining. So let's understand it carefully. I'm going from origin to 2 comma 1. So my x coordinate moved from 0 0, basically 0 to 2. This is the x, this is the y. So the x coordinate went from 0 at the origin to how much? 2. To basically 2 over here. The y coordinate at the origin would be 0 and finally the y coordinate is 1. So that's how you will give the limits. For x separately, for y separately. This is x and for here you will put y. Initial coordinates both are 0 because it was at origin. What is x's integration? It is x square by 2. Okay, so I'll just put this 0 and 2 over here. Y square's integration is basically y cube divided by 3 from 0 to 1. Okay, first put 2, then put 0. So it will be 2 square by 2 minus this will be 0 only anyways, minus this put 1 first, then put 0. So it will be 1 cube by 3 minus 0. So this will be equal to 2 square is 4, 4 by 2 is 2 minus this is nothing but 1 by 3. So 3 2s are 6, 6 minus 1 is 5. So 5 by 3 joules is the final answer. Everyone absolutely clear? NT square have answered already. Yes. So right, perfect. You are free. Let me know, guys, if you understood this amazing question. Yeah. Oh, ho, 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 Adarsh. Why did you put I cap, my dear? Why did you put I cap and j cap? Work is a scalar quantity. This is a common mistake. See over here that I cap vanished. It already vanished when I did the dot product. No, it has already vanished. So if you see this formula also, where did it go? Here, there is no, I'm not putting I cap, j cap. No, I'm saying this is a work due to the x forces, work due to y forces, work due to z forces. If you add them without any vectors, you get the final answer. It's a scalar addition. It's not a vector addition. So please, good we did this question, or else you would have done that mistake in the actual examination. Okay, absolutely clear, everyone? Amazing, amazing. Kudos to all of you. Okay, perfect. Now let us talk about kinetic energy, because then we are going to relate work and kinetic energy together. Kinetic energy is something which a body, particle, or mass, matter will possess because it is moving. Are you moving? Yes, you have kinetic energy. Are you moving? No, then you don't have kinetic energy. It's that simple. Okay, so this is nothing but the energy possessed by a body due to its motion. Now, if you remember, motion is relative. Motion is relative. So let's say I'm traveling in a bus and I'm carrying my suitcase. For me, the suitcase is at rest. But for a person standing somewhere on the ground, the suitcase is moving. So the suitcase is not moving for me in the bus. So for me, the suitcase has zero kinetic energy. But for the person standing outside, the suitcase is in motion. So the same suitcase has some kinetic energy. Some other person in another bus moving in the opposite direction will see a completely different speed. So he will measure completely different kinetic energy. So keep in mind that this kinetic energy is dependent on the frame. The final value, the dependency comes on the frame. Dependent on the frame of observation. Where are you observing it from matters a lot. Where are you observing it from matters a lot. Okay, great. So what's the formula, sir, for kinetic energy? The symbol is K. The formula is simply half mv square. That's it, nothing great. Half mv square. You have studied this in school level also. It is obviously a scalar quantity. There is no point of mentioning the direction. Even if you see, the sign of speed will get cancelled out. Okay, it will become always positive. Also, it can be measured in joules and ergs. And most importantly, kinetic energy is always more than, or worst case, equal to 0. But it can never ever be negative. It can never be a negative value. It is impossible because mass can't be negative, half is not negative, v square also can't be negative. So kinetic energy will always be a positive value. It will, like work can be negative, right? Work can be negative, can be 0, can be positive. Kinetic energy always positive, worst case 0. Nothing more, nothing less. Is kinetic energy also related to something else like momentum? Yes, definitely. And let's see how. See, kinetic energy is half mass into v square. So what we do, we'll multiply by mass and divide by mass. So it will become m square v square divided by m. We are preserving the equality. Okay. So this will become half. This m square v square, I will write it as mv square and divided by m. What is mass into velocity? That's momentum. So half p square by m is also kinetic energy. So a lot of times you will be needing it. In modern physics, in fact, you need the other way around. You take 2mk over here, and that is p square. And then you write momentum is root of 2 times mass times kinetic energy. So if you have some 12th standard kids out here, they will recollect, or probably a dropper student, that this expression is also useful in modern physics. Okay, so kinetic and momentum If you know one of this, you can automatically get the other. Either one of them, you remember. Either this or this. Don't have to remember both. It is anyways easy only. Either this or this. Cool. So kinetic energy is p square by 2m, or momentum is root of 2 times m times kinetic energy. One and the same thing. Perfecto. So now that the theory of kinetic energy is done, let's see some questions. When the kinetic energy of a body becomes 36 times, then how much is the change in the momentum of the body? Wow, what a question. Let's see. Think. Again, can you see? One word is kinetic energy, the other word is momentum. So the obvious answer is that you have to use the formula of K is P square by 2m. That is very obvious now which formula has to be used. So K is square of the momentum by 2 times the mass. Has the mass changed? No. Momentum changed? Yes. Kinetic energy changed? Yes. So can I say that K is directly proportional to P square now? Great. Now, can I say that the final by initial kinetic energy will be final by initial momentum the whole square? Okay, yes. What is the final kinetic energy as compared to the initial kinetic energy? It is 36 times the initial kinetic energy. Okay, is equal to, this is P final by P initial the whole square. Ki cancels, 36 is the square of this. So what will be the final by initial momentum? It will be root of 36. So therefore, the final momentum is 6 times the initial momentum. So this is the first thing which I got. Final momentum is 6 times more than the initial momentum, then the kinetic energy will become 36 times. But that's not the answer. The question is, what is the percentage increase in the momentum? This is the question. Percentage increase in the momentum. So percentage change in momentum. What is the meaning of change? Pandu meets Champa after a long time. Pandu tells Champa, Champa, you have changed. Why has he told that Champa has changed? He has compared original Champa, the OG Champa, with the current Champa. So final minus initial Champa. So same way, change in momentum means the final minus the initial momentum. So final momentum minus the initial momentum. When you calculate percentage changes, relative changes, you always divide it with the OG value, original value. Yeah. This is a change upon the original. So I've changed by 2 as compared to the original value of 100. So to convert it into percentage, you multiply it by 100. That's it. Right? If you don't put 100, it is a fractional change. If you just leave it like this, if you multiply by 100, it is the percentage change in the whatever value it is there. Yeah. Yes, we used it in moving charges also. Perfect. Now, what is the final momentum? It is 6 times of the initial momentum. Initial momentum is Pi as it is, and put 100 over here. Everything is in percentage. 6 minus 1 is 5. So 5 Pi by Pi multiplied by 100. So Pi cancels. So this will be 500%. A lot of people say 600. That is not the correct answer. The answer is 500. Many people look at this 6 times. Sir, it has become 6 times, sir. So 600%. No. The question is how much is the change? Earlier it was 100. Now it has become 600. So the change is 500%. Getting my point? Yeah, that's how you do these calculations. Let's go to the next one on your screen. There is a bullet of mass moving at this speed, emerges at this speed, percentage loss of kinetic energy. This was also previous year question. Can you believe these kind of questions are also asked in JEE Mains? But what to do? This is what is asked. Here, speed is there, and directly we have to figure out what is the percentage change in kinetic energy. So, in order to figure this out, change in kinetic energy, loss of kinetic energy, change of kinetic energy means your initial kinetic energy and final kinetic energy, you just subtract it. That will be the loss. If change is used, then it is final minus initial. Loss is used, then it will be initial minus final. Why? Think like this. Imagine Pandu had 20 laddus, now he has 18 laddus. If I ask you, what is the change of laddus? What is the change of laddus? It will be final minus initial, 18 minus 20, which will be minus 2. How many laddus did you lose? What was the laddus lost? 20 was there, 18 are remaining. So we'll just say 2 laddus are lost. So which is as good as saying it is 20 minus 18, which is basically 2. Initial minus final. So whenever that word loss comes, right, it is always initial minus final. So that is one thing. Upon the original kinetic energy, the whole thing into 100. Okay, this is all in percentage. Initial kinetic energy will be half mass initial speed square. Final kinetic energy is half mv final square upon half m initial is again vi square into 100. Half m cancels. So we are left with vi square minus vf square by vi square, the whole thing into 100. Let's start substituting. Vi, original speed 100. Okay, so put 100 over here also. Final speed 40. So just put 40 over here and then just put 100 right over here. Great. So what is 100 square? 1, 2, 3, 4. Minus 40 square, 1600. Divided by, again, 1, 2, 3, 4. And then over here, 100. That's it. Okay, start cutting out things, whatever you can see. This 0, this 0, this 0 cancels. Okay, what we can further do, this 0, this 0, this 0, this 0, this 0, this 0 also gets cancelled. Okay, so this will be 100 minus 16, which is basically 84. So 84% is the correct answer, which is C option right over here. Cool. Yes, very good, Virat. Wow, we have Virat Kohli in the class. Amazing. Everybody, till this point, absolutely clear? Great. Now, let's come to this concept of work kinetic energy theorem. Am I audible now? Oh, thank you so much, guys. Man, I was teaching. I don't know. I think from the beginning, so I'll explain. No worries. Okay. So, as I was saying, imagine this is some body, multiple bodies, some pulley blocks, spring mass, thread connected to two, three blocks, some blocks touching each other. There will be some forces within the system, which are called internal forces. There will be some forces from outside. Maybe somebody is pulling from outside, pushing from outside. Now, if you add the work by all these internal forces and the work by the outside external forces on this system, then that comes out to be equal to the change of the kinetic energy of the system. Change of the kinetic energy means final minus initial. So when you are pulling, pushing, etc., all these forces, one will speed up, one will slow down, maybe something will not change. So the kinetic energy, the speeds will change. So kinetic energy will change. So whatever work you have done, by all the forces will result in the change of the kinetic energy of the system. Yeah. Yes. Okay. So I hope this is absolutely clear. Great. I'm audible. All right. Yes, roar series is also enough, but I would suggest watch the current series. Unless you are watching some chapter which I'm going to do ahead, watch the roar, nurture, pathfinder. Anything is fine, man. Now, this also tells me one more interesting thing. Say, for example, my total work done is a positive number. My total work done is a negative number, and my total work done is 0. What does this tell you in the first scenario? If the total work done is positive, that means my change in the kinetic energy is going to be positive. That means my final energy is going to be more than initial energy. That means my speed will increase. The body which is there, because total work done is positive, like the Superman example. Like the Superman example. Where is our Superman? Yes, Superman pushing the bus. The speed is increasing. Work done on this body is positive. When it is negative, the speed will reduce. Work done is 0. You're just, that Godzilla was just rotating that car or that van. It was not increasing the speed, not decreasing. So speed was constant. So speed will not change. So this is exactly what this theorem suggests. So in this case, I will say the change of the kinetic energy will be negative. So final energy is less than initial. So therefore, the speed reduces. The speed reduces. And in the last case, there is no change in kinetic energy. Initial and final values are same. So the speed is same. Speed is constant. As simple as that. All right. The three different ones. Where to find Pathfinder? It is there here only. No man. Go to playlist. Go to playlist in the channel only. You can go over here. You will find it somewhere here. Nurture and Pathfinder. Oh, yo, so many playlists are there, huh? Man, we teach a lot, huh? I feel. We guys are teaching a lot. We should stop teaching, I feel now. My God. This is just in the last 1 year, huh? Nurture and Pathfinder. Ha, see here. Nurture, Pathfinder, everything is there. Chapter-wise playlists also I made. My God. Okay, I'll do one thing. I think I'll have to spend some time and you know, see, this is Pathfinder playlist. I'll have to sit and arrange these properly. How will I arrange? My God, it is going to take me so much of time, but I have to do it one day. I will do it, bro, someday. Hmm. Not pressure by volume, pressure into volume. Yeah, Chitra, that is in thermodynamics. Yes. I'm a YouTube online student, got 1410 rank in JEE Advanced, but my SAT score is 1510, so I decided to see schools in abroad. That is a very good move. If you are going abroad, go ahead, man. I mean, you can, it's a personal choice at the end of the day. So if you are getting a school abroad, please go ahead. I'm pretty sure you will love it, enjoy it, and don't regret anything. I mean, I'm pretty sure, in fact, you will enjoy it only. Yeah, I'm very glad, Virat. I think I should probably get in touch with you because I'm also planning to think about, sending students abroad, because a lot of kids these days want to explore the opportunity of studying elsewhere, and it's probably feasible by some upper middle class and middle class parents only, because you need some amount of money for that. So let's see. Maybe I will get in touch with you. You can just ping me on my Instagram or Telegram, Captain Shreyas. You can just search for it. Okay, Captain Shreyas. Right. Yeah. I have made a separate video, Vijay. Just search for Shreyas Sir Aerospace. I have made a separate video just for aerospace at IITs. Okay, just check it out. Anyways, now let's do some questions on work kinetic energy theorem. So let's start with a very interesting question. Oh, what is this? Let's start with a very interesting question right over here. Say, for example, there is a graph which is given, and this graph tells me the force versus displacement, and that graph goes like this, and then like this, and then stops abruptly over here. Maybe this value is, let's say, -10. This is, let's say, 20. This, let's say, is I don't know, maybe 4 meters. This is 6 meters, and maybe this is 7 meters, something like that. Okay. Question is, if the mass of the object is 2 kg, initial speed is also given to me as 20 meters per second. Find what is the final speed after moving 7 meters. After moving 7 meters, force versus displacement graph is given. What is the final speed? Beautiful question. Let's understand. Initial speed is given, final speed is given, graph is given. Why is the graph given? What exactly can we get from the graph? Let's try to understand. Oh, I know, sir. What can you get from the graph? This upper area will give me some positive value of the work, and this lower area will give me some negative value of the work. Force versus displacement area graph will give me work done. Oh, so let's calculate the work first. Oh, this is a trapezium, this is a triangle. So negative work here, half into the base into the height. Base is 1 unit, height is 10 units. So 1 into 10. So this will be -5 joules. If you ask me here, it is a trapezium. So half into sum of parallel sides. One is 4, the other is 6, multiplied by the height of the trapezium, which is basically 20 units. So 20 by 2 is 10, 4 plus 6 is 10, 10 tens are 100. So 100 joules over here. So we now get the total work done, which is 100 minus 5, which is nothing but 95 joules. 95 joules is the total work done. Everybody? Yes. What do I do with the total work? Speed. They are related. Kinetic energy, work kinetic energy theorem. So the total work done by all the forces is final minus initial energy. The total work done is 95. Final will be half into the mass into final speed square, and initial will be half into mass into initial speed, which is 20 square. Oh, got it. So this will be 95. 2 cancels. This will be VF square minus 2 cancels. 20 square will be 400. Bring that 400 here. So VF square will be 400 plus 95, which is 495. So that's it. We get VF as root of 495 meters per second. You can just leave it like that. That's it. So what a brilliant question. From area under the graph, calculation to the work using the sign convention, and then using work kinetic energy theorem. Yeah, is that right, everybody? Perfect. Yeah, it will be slightly more than 22 because 22 square is 484. So it will be like 22.2 or something like that, around that range. Anyways, Now going to the next question coming up on your screen. Now this is also amazing question. Let's see if you can figure it out. Okay, right. Just get it a duplicate. Hmm. In this particular question, there is a thread which is pulling up a block, a thread which is pulling up a block by some force, and this mass is, let's say, 5 kg. Okay, and you are making it accelerate. You are making it accelerate at, let's say, 2 meters per second square. You start from rest. You start from rest and move for 2 seconds. Question is, find the total work done. Find the total work done on that particular object. Find the total work done on that particular object. Now, let's say we didn't know work kinetic energy theorem. Then what I would do is I would show the forces on it, like the weight. Then I would also show there is some kind of tension here. That's it. And I will try to find the work done by each force and add them to get the total work. But before we find the work, we need displacement. So we need to find that out also separately. Okay. I'm going at 2 meters per second square. I'm going like this. So definitely there will be some displacement. Use ut plus half at square. Initial speed started from rest, so 0. Acceleration 2. Time 2 seconds. Okay. So 2 to cancel. This will become 4 meters displacement. Now let's calculate the work done by the tension. It will be the tension multiplied by displacement multiplied by the angle cos. Tension is here, displacement is here, angle is 0. So cos 0. How much is the tension? Oh, lot of you are going to say, sir, tension is equal to 5g. Bro, that is wrong. Why? Because they are not going to be equal, because it is accelerating. Oh yeah, right. Actually, using Newton's laws, tension minus 5g will be the mass, which is 5, multiplied by acceleration. So we are using Newton's laws of motion over here to get this. Okay, perfect. So tension minus 5g means 5 into 10 is equal to mass into acceleration over here, which is nothing but 5 into 2, which is nothing but 5 into 2. So therefore tension will be 5 into 10 is 50 plus 5 to the 10. So therefore tension is 60 newtons. Tension is 60 newtons. So substitute that over here. Displacement 4, cos 0 1, 6 4s are 24, so 240 joules. So that is the work done by tension. Everybody fine till here? Now let's figure out work done by mg, which is weight. It will be the mg force multiplied by displacement multiplied by cos. Force and displacement are opposite, so cos of 180 degrees. Mg force means 5g, so 5 into 10. Displacement, oh sorry, it is 4. Cos 180 means minus 1. 5 4s are 20, so minus 200 joules. Minus 200 joules. But that's not the end. You have to find the total work. So total work will be this 240 plus this negative 200. So that's going to make it 40 joules. Wow. We got the answer. But sir, this is so lengthy, sir. Newton's laws, kinematics, work by everyone, adding them. I got such a headache. Simple way. Let's try to do it using work kinetic energy theorem. For work kinetic energy theorem, what do we exactly need? Let's see. The total work done will be final minus initial energy kinetic. So it will be half mass V final square minus V initial square. Oh, is the mass given? Yes. 5 kilos. Is the final speed given? No. Is the initial speed given? Yes, it is 0. So I just need the final speed. And very easy to calculate the final speed using U plus AT formula. Initial speed 0, acceleration 2, time also 2. So it will be 4 meters per second. So use this number 4 right over here. And there you go. It will be 5 by 2 and 4 square is 16 minus 0. Yeah. So 16 by 2, 8, 8 5 is a 40. how easy it became using work kinetic energy theorem. That's what I believe. I was trying to explain you the significance of work kinetic energy theorem. So some problems, work kinetic energy theorem can be very, very useful. Can be very, very useful. Yes, very good, Azad. Dilip, you questioned the system. Now let's go back to one question which we had said that we'll do it now. I think it was this one. Yeah, I guess so. Look at it. JEE 2024 question. There is a particle which moves in a straight line. The speed is changing with this equation. Look at that equation. Alpha root x, where alpha is some constant. When x changes, speed also is changing. Okay. The total work done by all the forces in moving from this to this will be how much? Now I'll tell you what is so weird about this problem. Okay, let's see. If you want to find the work done by all the forces, and I say, sir, I will integrate it from initial location to final location. Okay, so be it. What is the force? Ayyo, force only is not given. Okay, dx I will put. Initial location to final location, x equals to 0 to x equals to d. So 0 to d. What will you? Force only is not given. So then you will say, okay, sir, I know what to do. Force is mass into acceleration. Okay. Sir, now acceleration is not given. Oh, then you will do dv by dt. But you can't differentiate velocity with time because this is a function of x. Oh, then I will write chain rule dv by dx into dx by dt. See, oh, dx by dt is velocity. So dv by dx into v. So, the problem is becoming scarier and scarier and scarier. It is like horror movie is not ending. It is becoming more horror. It's not becoming comedy. So I don't like this. Getting my point? What we just did. Usually work is forced into displacements integration. Why integration? Because I saw it's some x and y and all that is there, means variable only. But force I don't know. Force is ma. A I don't know. A is dv by dt. But I can't differentiate velocity with time like this because it's a function of x. I can differentiate with x only. So I use chain rule. And from chain rule, I saw dx by dt is v. So again, I have to put v. Again, I have to differentiate. It's a headache. Can you see that? Thank you, Jaswant. What I will do instead, work. Oops, sorry. I shouldn't do this. Yeah. What I can do instead, I can instead use work kinetic energy theorem. How? Let's see. The total work done by all the forces is asked, which is final minus initial energy, which is half into mass into V final square minus V initial square. Interesting. So I'm just going to put half m over here and let's see what happens next. I don't know the final speed and initial speed, so be it. I think we can find it from here. Look at it. This is the initial condition. This is the final condition. So if you ask me what will be the initial speed, use this equation alpha and x, you will substitute it as 0. So root of 0 is 0. So 0 into donkey is 0. So basically 0 into anything is 0. That's what I meant. Okay. Then V final is again alpha into root of x. What is x? Final position is d. Oh, so it is basically alpha root of d. I think we just got it. So V final is alpha root d. V initial is 0. So now we're going to square this and we're going to square this. Okay. So m by 2 alpha square d minus 0. So it is just going to be m alpha square d by 2. We didn't even integrate, we didn't even differentiate. So that's it. That's the answer, my dear warriors. M alpha square d by 2, which is C for Captain Shreyas. Understood the significance of work kinetic energy theorem? How many of you got it? Yeah. This is divided by 2 alpha square d. That alpha square d is in the denominator, so that's why A is not correct. Yeah. Okay, Virat, this is not the same. Okay, this is not m by 2 separate and alpha square d separate. No, it is m divided by alpha square d2, which is completely different option, which is not correct. Okay, I'm so glad you guys loved it. And that was the final question. And I have also given you the homework question for today. Please solve it. Where is my homework, man? Homework here. I have written homework also. Answer is there on the next slide. with the solution. Where can you find it? PDF. Where will you get PDF? Comment section after one day, and in the description box also the link will be there. We store it on our servers. So even after 1 year you watch it, you are still going to get the PDF. Or else if you upload on Telegram, you will lose it. You don't know where to find it. All that nonsense. Okay, great. So make sure you're registering for MVSAT also. In case you haven't done it yet, please do that. And like this video, share this video, talk about the channel Vedantu JEE English, talk about Captain Shreyas Sir, your sir, who is going to guide you throughout the journey 2026, 2027, 2028, 2029, 2030, everything, guys, on this channel. And subscribe and like this video. Thank you so much. Bye bye. Happy Ganesh Chaturthi once again. Take care.